Our notes on conditional statements will begin on page 14, and conditional statements are if-then statements. So a conditional statement is one that you can be written in the if-then form. And then when you're looking at the if-then form, the hypothesis is the part that follows the if, and then the conclusion is the part that follows the then. A conditional statement can be represented using symbols as well. So if you see P references the hypothesis, and the Q part represents the conclusion. So the arrow can be read as P implies Q, or if P then Q, where P is the hypothesis and Q is the conclusion. So now we're going to go through a series of examples. If I live in Fountain Valley, then I live in Orange County. In the above statement, we're going to underline the hypothesis and circle the conclusion. So underline the hypothesis and circle the conclusion. So the I live in Fountain Valley part is the hypothesis, and then the conclusion is I live in Orange County. For the next example, underline the hypothesis with one line and conclusion with 2 lines. So if B is the midpoint of AC, then AB is equal to BC. So that should look familiar to us because that is what the definition of a midpoint is. Lots of definitions, lots of theorems and postulates are described using conditional statements. So here our single underline for the hypothesis and then double underline for the conclusion occurs after the then part. Okay, so 2, we have to be careful. It says a number is divisible by 10 if its last digit is 0. So the if part now comes at the tail end, so I'll single underline the hypothesis. The conclusion comes before this time. Now sometimes you'll be asked to write an if-then statement given a statement. So a mammal is a warm-blooded animal. So if I were to rephrase that as a conditional statement, if an animal is a mammal, then what can we conclude? Then it is warm-blooded. If it helps you to type your homework because there's lots of writing, I'm fine with that as well. So when we're doing this part, if you change the hypothesis or conclusion of a conditional statement, you can form related conditionals. And related conditionals are important because we'll find that certain statements are related to another statement, which is true. And then certain statements that are related, written in a different context, called the converse and inverse, are related to each other, whereas the conditional and contrapositive we'll see are related to each other. And their relationship will have what we call the same truth values. And a truth value simply is that if one is true, the other one must be true as well. So a conditional is, remember, an if-then statement. So if blank, then blank. So when I'm writing the converse of it, I'm switching the if and the then part. So if I'm going to use the above as an example, so rather than if an animal is a mammal, I'm going to start with if an animal is warm-blooded, so I'm switching the P and the Q part. An animal is warm-blooded, then it is a mammal. So many times with definitions, we find that if the initial conditional statement is true, its converse is true as well. So for the inverse has a not tied to it. So if we go back to our original conditional, if an animal this time is not, so we're going to add that. It's called negating. Sorry, spelled animal wrong here. So if an animal is, and what I'm going to do is insert in red the part of it that changes the conditional statement. If an animal is not a mammal, then it is, and then again, adding the not and making it negative, then it is not warm-blooded. And finally, the contrapositive, the word that has the longest statement, actually does two actions. It negates it as well as flips it. So the P and the Q part switches as well as adding a not to it. So if we're going to switch it first, we're going to have the warm-blooded part come first. So if an animal, and then negated as well, is not warm-blooded, then it is not a mammal. All right, and the key part is we're adding the not as well as we're switching. Erase that arrow, and then we'll summarize the rules as well. So a condition is if P, then Q. A converse is we switch the Q and the P. An inverse is go back to the original statement and then we negate it. So not P, not Q. So that's new symbols to you guys, that tilde means not P, then not Q. And a contrapositive does both. It switches as well as negates. So not Q, then not P. And let's go ahead and use that symbol up here as the symbol is not. It's a negation or making it the opposite. Okay, so now below there, after each statement, write the truth value, true or false. So we'll write the converse, inverse, contrapositive, and then write if it's true or false. So if the measure of an angle is 35 degrees, then A is an acute angle. So we're going to, is that true or false? We're going to determine that truth value, and that is true. If angle A is 35 degrees, then it is less than 90 degrees, therefore it is an acute angle. The converse would be, we switch P and Q, so if angle A is an acute angle, then it measures 35 degrees. Is that true? If an angle is acute, does it necessarily mean that it has to be 35 degrees? And no, that's not true. So that the truth value for the converse is false. An inverse, again, is adding nots to the original conditional. So if the measure of angle A is not 35 degrees, then angle A is not acute. That's also false, because if it's not 35 degrees, it could be anything less than 35 or greater than 35, which then means it could be acute or it could be obtuse or it could be 90 degrees or a right angle. So that statement is false. And then the contrapositive is switching and negating. So if angle A is not an acute angle, then the measure of angle A is not 35 degrees. Is that true? If angle A is not an acute angle, then the measure of angle A is not 35 degrees. Well, that's true. If it's not acute, it must be obtuse or right, which then means it's not possible for it to be 35 degrees. So this is true. And so what we notice is that the truth value, we can say consistently after this that the conditional and contrapositive both always has the same truth value. So if one is true, the other one is true. If one's false, the other one's false. And the same applies for the converse and inverse. It has the same truth values. If the converse is true, then the inverse is true. If one is false, then the other is false.